Today, we're going to follow the incredible journey of a signal. We'll see how it goes from being just a physical thing happening in the world, like a change in temperature or a sound wave, all the way to becoming a meaningful action. This whole process, the sort of invisible magic that powers so much of our tech, is all thanks to something called an instrumentation system. So think about this for a second. How does your smart thermostat actually know the room is cold? It doesn't have feelings, it can't shiver, so how does it decide it's time to kick on the heat? Answering that simple question is going to unlock the secret behind tons of devices we use every single day. And the answer is right here, an instrumentation system. The best way to think about it is like a little team of specialized gadgets all working together in a chain. Their job is to measure something physical, make sense of that measurement, and then actually do something useful with it. All right, let's break down the game plan. This diagram right here is basically our map. Pretty much every instrumentation system follows this exact path. It all starts out in the physical world with a medium, which gets picked up by a sensing element. That signal then gets cleaned up by a signal conditioning element, and then the signal processing element figures out what it all means, which finally leads to some kind of action. So let's walk through this step by step. Our first stop on the journey is where the system makes first contact with the real world. How does it even start to measure something? Well, that's part one, sensing the real world. It all kicks off with something called the medium. And that's really just a fancy term for whatever physical thing we're trying to measure. It could be the pressure inside a car tire, the brightness in a room, or, how fast a motor is spinning. So let's bring it back to our thermostat. What's the medium? Simple. It's just the air in the room. That's the physical thing that our entire system is designed to keep an eye on. Easy enough, right? So how do we detect that medium? Well, we use a sensing element, but you and I would just call it a sensor. This is the part that literally interacts with the physical world. For example, a thermistor changes its electrical resistance based on temperature. A strain gauge actually bends when it feels force or pressure. And an LDR, or light-dependent resistor, reacts to how bright the light is. Each one is a little specialist, built to turn some physical property into an electrical signal. Okay, so our sensor has given us a signal, but here's the problem. That first signal is usually like a really faint, scratchy message. It needs a serious cleanup before it's any good to us. So welcome to part two, cleaning up the message. So why do we even need this step? Well, that raw signal from the sensor is almost always a bit of a mess. For one, it can be incredibly weak. We're talking like a whisper in a crowded stadium. It can also be filled with all sorts of electrical noise and interference, kind of like static on an old radio. And sometimes it's not even in the right format for the next part of the system to understand. And this is where signal conditioning becomes the hero. It's a whole cleanup process. First, amplification boosts the signal, turning that whisper into a nice, clear voice. But here's the catch. When you amplify the signal, you often amplify all the noise right along with it. That's why the next step, filtering, is so important. It gets rid of all that static and isolates the pure message. Sometimes you also need linearization, which just makes sure the signal is a true representation of the measurement. Back in our thermostat, this stage is absolutely critical. It takes that tiny, fragile electrical flicker from the temperature sensor and transforms it into a strong, clean, and totally reliable signal that's ready for the brains of the operation. So now we've got a strong, clean signal. Awesome! But a signal is just raw data. It doesn't actually mean anything by itself. Now it's time to figure out what it's trying to tell us. This brings us to part three, processing for meaning. Okay, this is the brain of the entire system. But before this brain can do any thinking, it needs the information in a language it can understand. That's why the first step here is a big one, analog to digital conversion, or ADC. It basically takes the smooth, continuous analog signal from the real world and translates it into the ones and zeros of the digital world. Only then can a little computer chip or microcontroller actually process the data and make a decision. So here's the moment of truth. The thermostat's tiny computer brain takes that digital signal, does the math, and figures out, okay, this represents a temperature of 68 degrees. Then it compares that to your setting of 70 degrees and makes a logical decision. Hey, it's too cold in here. We've sensed the world, we've cleaned up the message, and we've made a decision. There's only one thing left to do. Act on it. Welcome to part four, the final output. And that final action can take a whole bunch of different forms. It might be something as simple as just displaying the value on a little LCD screen. Or it could be storing that data in a memory chip for later.
Or, and this is where it gets really powerful, it could control an actuator, which is something like a motor, a valve, or a switch to physically change something in the real world.
Our trusty thermostat is a bit of an overachiever because it actually does two things. First, it handles the signal by displaying 68 degrees F on the screen so you know what's going on. And second, based on its decision, it sends another signal to an actuator, in this case, the relay switch that turns on your furnace. And just like that, the journey is complete. And this brings it all together beautifully. We started with the medium, the air in the room, the sensing element detected the temperature, the signal conditioning element cleaned up that message, the signal processing element made a decision, and finally, the target signal handling element took action. From a physical thing to a final action. Every one of these systems follows this exact same path. So the next time your phone automatically adjusts its screen brightness or your car's dashboard lights up to tell you your tire pressure is low, you'll know the secret journey that signal took to make it all happen. So here's a final thought for you. What other invisible instrumentation systems are working all around you right now? Something to think about. Thanks for watching.